Hello, good morning, students. Today we are going to discuss the topic on AI foundational models, scaling laws, and emerging capabilities. Here, the learning outcome of this topic is to identify and understand the various foundation models and how to apply the scaling laws and various emergent capabilities and applications. So, when you look at the timeline here in 2000s, machine learning got evolved and deep learning has been introduced in 2010s. And in the recent decade of 2020s, foundation models has been introduced and adapted, like LLM, etc. So here the feature-centric difference is in the 2000s, the models and tasks were differentiated, but in 2010s, models and were integrated with the pre-trained systems and with the classifier. So the tasks have been completely integrated with the model. In 2020s, the data took a major role, so that helps a lot of things for the generative systems and generative tuning model. And let's have the ice-breaking question with the recap. How does the ChatGPT is answering the unseen questions? So here is the flow. This flow is being understood only with the knowledge of machine learning and how the deep learning it works and what is the role of transformers in the generative AI. So initially you are prompting a question, you type it, and then the words are broken into tokens. We call that process, we call it as tokenizations. And each prompting is understood as a tokens, right? And the words are turning into numbers. Then the transformer it is kicking into the trained data sets where it uses everything whatever it learned during the training process. Then the writing of answer process is happening. It is being framed one word at a time. And it turned all the black back into the human language finally. So here the loop it continues whenever you prompt for the further questions. So this is the mechanism of the chat GPT, how it is answering to the user queries. So here the session objectives is to define the foundation model, what exactly it is, and to understand the scaling laws, and also to explain the various emergent capabilities and applications. So there are five scaling laws. One is pre-training process, where the resources and data ingestions is happening, and post-training, where we talk about the reinforcement learning and specialized capabilities. And in other three things are like the AI engineers, how they are having the innovation and diffusion process, how they are doing it. And for the better designs, in what kind of effectiveness they are achieving with the business value. Finally, the computational cost and the inference quality is achieved through the test time reasoning. So let's take the problem statement. An employee, AI product manager, Ananya, she's found facing a challenge of building an AI which looks generalized across various tasks. And she found the cost, speed, and user experience are completely varied. So when we have empathization on this particular problem, we need to define the large level language models. We call it as LLM. When we evaluate the LLM, we come to know the various evaluation categories, the task specific benchmarks, and the hallucination testing, how the human preference is being rating, and the other tools. So here the foundation model, not just LLM all the times. Here we have a supervised learning where it takes the transfer of information with the other components like GPT and the examples of generative AI tools like Gemini, Claude, and LLM. In all the generative AI tools, there is a common things are happening. Like annotated data is completely in the corpus. It's a large corpus. Then from that, the unsupervised learning task is being triggered. Then with the pre-trained model like BERT and all, the predictions are happening with the proper fine tuning. And finally, the fine tuning is done with the task-specific data and with the labels. And when we look at the architecture of LLM, we could see the three different verticals of prompt engineering and fine-tuning process and RAG. So resource allocation graph. So in all the three cases, the architecture, it talks about the attention mechanism and how the patterning of data training is happening and how the fine-tuning is happening with respect to prompt engineering. So these are the most important things about when it comes to dealing with the foundation model. And here the scaling laws, when you look at the timeline, you can see that from June 18 what was the prediction had happened, and in the February 19, and we came across recently May 20 and 2021. If you see that OpenAI, when it got introduced 18, and GPT-2 got introduced 19, then T5 architecture was introduced in 19 October, and finally GPT-3 has been recently introduced in the 4 years back, and with the more billions of parameters. So you see that every time the million parameters have been differentiated from million to billion. So this is a generalization cost. It is in a larger scale. The growth also, it is happening in various trends. And emergent capabilities, if you look at that, we talk about a few shot prompting, like with the proper reasoning, and with the code generation is another example, and translation and problem solving is also another example. You see that there are three types of shot, zero shot, one shot, and few shot. But the examples are given with the prompted images. Right. Then finally, in ideation phases, we are seeing the five different layers, uh, like the input layer, and decision layer, output layer, encoding layer, and fusion layer. In all the layers, the common process is to fine tune the prompt, and the information is being processed via the resource allocation graph. With the support of multimodal AI and agentic AI, we are able to generate the high quality aesthetic outcomes of images. Here, the prototype is demonstrated with the example of customer support assistant, where the intent has to be detected of customer. Then finally, the knowledge base is being referred with the support of external tools and safety and guardrails. It is processed with high confidence and low confidence. If it is high confidence, means the automated response. If it is low confidence, means the human response is expected. And with the case study of understanding, let's take a hospital, how the AI assistant scenario is happening. You people have to have a discussion, you form a team, and you have to present your ideas. So here I have given some of the use cases of AI health assistant, from automated appointment, or you can take an example of mental health support, or you can take a example of clinical decision support, or virtual nurse, how she can take care of the post treatment care. So you can have, even you can think about the chatbots and remote monitoring, symptom checking, etc. So, however, the final conclusion, how to build a foundation model, we require pre-trained data. With the fine tuning, we can achieve the inference. With the inference, we can uh, deploy the model, training model, to generate the final outputs. We need to follow or safeguard with the quadriles. And here the summary, you can see the data, how it is used, multimodal things, and trained foundation model, how it takes a major role in adapting the various tasks like sentimental analysis, information extraction, image captioning, etc. Thank you. Let us see in the next class.